Hello everyone, today we're going to talk about element number 48, cadmium. So cadmium is perhaps best known for its use in nickel-cadmium and NiCad batteries, though these days they are being replaced in many applications by nickel metal hydride and lithium-ion batteries that are lighter, more powerful, and less toxic. Cadmium, unfortunately, is a lot like lead, element number 82, and mercury, element number 80. In that it accumulates both in the environment and in the body, causing long-term damage to life everywhere it is found. This is why nickel-cadmium batteries should be taken to stores or collection points that recycle them, not thrown in the garbage where their cadmium will eventually get into the environment. The other place you will find large amounts of cadmium is in cadmium-plated fasteners, used these days mainly on aircraft. While common zinc plating is good enough for domestic applications, cadmium offers an unbeatable combination of properties when it's really important that a given bolt not rust or cause corrosion of the parts it's touching. For example, if it's the bolt holding the landing gear of the airplane you're in. One bright spot with cadmium is cadmium yellow, an extremely intense pigment favored by the Impressionists. Claude Monet, asked about the colors he used, replied, "In short, I use white lead, cadmium yellow, vermilion, madder, cobalt blue, chrome green. That's all. 4 elements in one quote. Not bad for a painter." Since vermilion is mercuric sulfide, Monet's favorites constitute practically a full house of toxic pigments, missing only Paris green, which consists of arsenic, as mentioned in the arsenic video. So here we have 3 different types of batteries. We have the lithium-ion battery, we have the nickel metal hydride battery, and we have the nickel-cadmium battery. Again, the nickel-ion battery and other various types of batteries are more powerful and less toxic than a cadmium battery. The heavy metals commonly associated with poisoning of humans are lead, mercury, arsenic, and cadmium. Heavy metal poisoning may occur as a result of industrial exposure, air or water pollution, foods, medicines, improperly coated food containers, or the ingestion of lead-based paints. So here we have some information on Oscar Claude Monet. He was a French painter and founder of Impressionist painting, who is seen as a key precursor to modernism, especially in his attempts to paint nature as he perceived it, according to Wikipedia. Mercuric sulfide, which is vermilion, which consists of the elements mercury and sulfur. Hg is the symbol for mercury. So cadmium is a poison and is known to cause birth defects and cancer. As a result, there are moves to limit its use. 80% of cadmium currently produced is used in rechargeable nickel-cadmium batteries. However, they are gradually being phased out and replaced with nickel metal hydride batteries. A nickel metal hydride battery is a type of rechargeable battery. The chemical reaction at the positive electrode is similar to that of the nickel-cadmium cell, with both using nickel oxide hydroxide. However, the negative electrodes use a hydrogen-absorbing alloy instead of cadmium, according to Wikipedia. Cadmium was often used to electroplate steel and protect it from corrosion, like tin or zinc. Other past uses of cadmium included phosphorus in cathode ray tube color TV sets, and yellow, orange, and red pigments. Cadmium absorbs neutrons and so is used in rods in nuclear reactors to control atomic fission. Here we have some information on nuclear reactors. Phosphor is solid material that emits light or luminesces when exposed to radiation such as ultraviolet light or an electron beam. Hundreds of thousands of phosphors have been synthesized, each having its own characteristic color of emission and period of time during which light is emitted after excitation ceases. So here we have some information on corrosion and cathode ray tubes. A cathode ray tube is a vacuum tube containing 1 or more electron guns, the beams of which are manipulated to display images on a phosphorescent screen. The images may represent electrical waveforms, pictures, radar targets, or other phenomena. A CRT on a television set is commonly called a picture tube, according to Wikipedia, which is why it's called YouTube, because of the cathode ray tube. Silver white and capable of taking a high polish, cadmium is nearly as soft as tin and, like tin, emits a crackling sound when bent. It can be rolled out into sheets. Cadmium melts and boils at relatively low temperatures. Its vapor is deep yellow and monatomic. This metal is permanent in dry air, becomes coated with the oxide in moist air, burns on heating to redness, and is readily soluble in mineral acids. Poisoning results from the inhalation of vapor or dust of cadmium. Friedrich Strominger, a German chemist, discovered the element in 1817 in a sample of zinc carbonate. And in the same year, KSL Hermann and JCH Roloff found cadmium in a species of zinc oxide. Both zinc compounds were being examined because their purity as pharmaceuticals was suspect. Here we have some information on cadmium oxide, and here we have some information on zinc monocarbonate, which consists of zinc, carbon, and oxygen. So again, cadmium fumes are poisonous, so please avoid the fumes because they're bad for your health. Cadmium is toxic, carcinogenic, and teratogenic, which means that it disturbs the development of an embryo or fetus. On average, we take in as little as 0.05 milligrams per day, but it accumulates in the body, and so on average, we store about 50 milligrams. Before the dangers of cadmium were fully understood, welders and other metal workers were at risk of becoming ill. Wait! No! In 1966, some welders working on the Seven Road Bridge became ill from breathing in cadmium fumes. Exposure to cadmium and cadmium compounds can cause cancer of the lung and may cause cancer of the prostate and kidney. Cadmium is also on the Proposition 65 list because it can cause birth defects or other reproductive harm. Exposure to cadmium may harm a man's reproductive system. In the early 1800s, the apothecaries of Hanover, Germany, made zinc oxide by heating a naturally occurring form of zinc carbonate called cadmia. Sometimes the product was discolored instead of being pure white, and when Friedrich Stremeyer of Göttingen University looked into the problem, he traced the discoloration to a component he could not identify and which he deduced must be an unknown element. This he separated as its brown oxide, and by heating it with lamp black carbon, he produced a sample of blue-gray metal which he named cadmium, after the name for the mineral, cadmia. That was in 1817. Meanwhile, two other Germans, Karl Messner and Karl Karsten in Berlin, were working on the same problem and announced their discovery of cadmium the following year. So we mentioned apothecary. An apothecary is one who prepares or sells drugs or compounds for medicinal purposes. So cadmium, a rare element, about 0.2 grams per ton in Earth's crust. Cadmium occurs in a few minerals and in small quantities in other ores, especially zinc ores, from which it is mainly produced as a byproduct. The chief zinc ore, zinc blende, or safflorite consists mainly of zinc sulfide containing from 0.1 to 0.3% cadmium. All methods of zinc production begin with the conversion of the sulfide into zinc oxide by roasting. The cadmium becomes concentrated in fumes, which are treated in various steps until a product is obtained over 99.9% cadmium. Some lead ores also contain small quantities of cadmium, and if it is present in sufficient quantity, it is recovered by a cycle of operations similar to that used in zinc smelters. Zinc producers who use the electrolytic process recover cadmium in a somewhat different way, but again the principle is the same, beginning with the roasting of zinc sulfide followed by the treatment of the flue dusts. Flue dust is finely divided metal or metallic compounds escaping with the flue gases of a smelter or metallurgical furnace. China, South Korea, Canada, Japan, and Kazakhstan lead the world in cadmium refinement in the early 21st century. Most cadmium produced is electroplated onto steel, iron, copper, brass, and other alloys to protect them from corrosion. Again, a quick review. Steel is a combination of iron and carbon, and brass is a combination of copper, lead, and zinc. Cadmium plating is especially resistant to attack by alkali. Cadmium is physically similar to zinc, but it is denser and softer. The plated cadmium has a smaller grain size than electrozinc coatings, and deposits tend to be more uniform and smooth. Consequently, good protection is afforded by thin coatings of cadmium, and thus, in spite of its high price, it is frequently used for the protection of precision parts. Its resistance to marine atmosphere is also superior to that of zinc. An important application of cadmium is its use as the anode with either nickel or silver oxide as the cathode and a caustic potash electrolyte in rechargeable electrical storage batteries for uses in which lower weight, longer life, and stability upon storage in discharge conditions are desirable as in aircraft. Cadmium combines with many heavy metals to yield alloys. The most important are bearing alloys and low melting alloys used for brazing. The small quantities of cadmium added to the heavy metals strengthen them. 1% added to copper increases its strength and hardness with only a small reduction in electrical conductivity. Alloyed with zinc, cadmium forms solders with good shear strength. Because it efficiently absorbs thermal neutrons, it is used in control rods for some nuclear reactors. The only mineral containing significant quantities of cadmium is greenockite, which is cadmium sulfide. It is also present in small amounts of safflorite. Almost all commercially produced cadmium is obtained as a byproduct of zinc refining. Here we have cadmium. Just another gray, shiny transition metal, you might think. I'm a super stable element, which means that when I'm mixed into steel or used to plate it, the steel doesn't corrode. Boring. But wait, beneath my bog standard exterior, I'm a flamboyant show-off. I got swagger. You see, when my atoms combine with other atoms and molecules, I burst out in bright reds, wild yellows, and glorious greens. My compounds make great paints. The famous artist Monet used to swear by my quote-unquote cadmium yellow. I also team up with nickel in rechargeable batteries. Like most braggers, too much of me will make you sick. Like mercury and lead, I tend to build up in the body if I make my way into water supplies and the food chain. This is why it's important to recycle your batteries properly. Its date of discovery was in 1817. Its density is 8.65 grams per centimeters cubed. Its melting point is 321.07 degrees Celsius or 609.93 degrees Fahrenheit. Its boiling point is 767 degrees Celsius or 1,413 degrees Fahrenheit. Here we have cadmium. During the refinement and production of zinc from its ore, cadmium is extracted as an impurity. This metal was once used to make vibrant yellow paint but is no longer used as it is now known to be highly toxic. Today, cadmium is used mainly in rechargeable batteries. Its atomic mass is 112.414. Its state is solid. Its discovery was in 1817 by Friedrich Strummer. This mineral is mainly composed of cadmium sulfide. Here we have greenockite, an ore of cadmium. So that was cadmium explained in as a short amount of time as possible. If you like this video, make sure to like, comment, subscribe. Other than that, thank you everyone for watching. Have a great one.